Assalamualaikum warahmatullahi wabarakatuh. Today, we will present to you about lens, and we also we only present to you about concave lens. Alright, we start with the definition of lens. Lens are made of transparent materials such as glass or clear plastics. They have two faces, of which at least one is curved. Alright, we will focus more to the concave lens. Alright, concave lens have three lenses. First, we have biconcave, and we have plano-concave, and last is we have concavo-concave. Alright, as we can see, biconcave has two faces that curve. Two curved surface, yes, and plano-concave has one curved surface, but the different between the plano-concave and the concavo-concave is plano-concave. As we can see here, it is more thicker than concavo-concave. Alright, this is the differentiation. Concave lens or diverging lens. We call this concave lens as a diverging lens, but while the convex lens we call as converging lens. Alright, concave lens is thinner at the center, as we can see here. At the middle. At the center, the lens is very thinner. It's thinner than the convex lens. Okay, next, focal point and focal length of lens. Alright, f is a focal point or principal focus, and the f and the capital F1, and the small f is a focal length. Focal length is distance between the focal point f and the optical center C on the lens. So f is the distance between F and C. C is optical center. So the black arrow is light rays, and the f-axis is the principal axis. So the green dot is a focal point. Alright, rules for ray diagrams. Okay, we more focus to concave lens. So first, the ray parallel to the principal axis is refracted as if it appears coming from focus point F, which is located at the same side of the incident ray. Alright, we can see here the ray is move in a straight line, right? So when it's passed through the concave lens, it will bend the incident ray. Alright, we can see here the ray is move in a straight line, right? So when it's passed through the concave lens, it will bend. The ray will bend. Passing through the concave lens. Alright, the second one, the ray passing the focus point. The ray passing the focus point is refracted. Dibiaskan is refracted parallel to the principal axis. So here, the light rays is refracted, and it's become refracted parallel to the principal axis. And the third one, the ray passing through the optical center travels straight on without bending. So the light rays go passing through the concave lens without bending. Alright, ray diagrams for concave lens. Alright, here is the formula for the concave lens. So we have to remember the formula if you want to score A+ in your physics. So here is the formula. F is smaller than U is smaller than 2F. F is just like I told you before, F is the focal point, or the focal point. So means the distance between the optical center and the principal axis, or what we call as focal. It's okay. So this is the object, and the blue arrow one show the R3 show this one. This rays concave lens, that the ray passing through the concave lens without bending, and the red arrow one shows the first one that shows before the first one. The ray parallel to the principal axis and is refracted to the concave lens. Okay, with diagrams of concave lens. So this is such a sample for questions. We are such example. So 2F and F and focal point and the O. O is the lens, and also here. So as we can see, U is equal to 2F, and here U is smaller. Show this one. This rays concave lens, that the ray passing through the concave lens without bending, and the red arrow one shows the first one that shows before the first one. The ray parallel to the principal axis and is refracted to the concave lens. Okay, with diagrams of concave lens. So this is such a sample for questions. We are such example. So 2F and F and focal point and the O. O is the lens, and also here. So as we can see, U is equal to 2F, and here U is smaller than F. So the object distance U, as we use this formula. Okay, the power of lens. Before we end up all this, we have to learn about the power of lens. So the power of lens is a measure of its ability to converge or to diverge. Converge is convex, and diverge is concave. Remember this: converge convex, diverge concave. Remember. And incident beam of light. SI unit for this calculation is M -1, or diopter. D, capital D, no small d, capital D. Okay, this will if you get wrong with this question, you only waste your marks, because it is simple questions. And the third one, power for a convex lens is positive. Power for a concave lens is negative. Alright, we remember this. Concave is always negative and convex is always positive. Okay, so we also have to remember this. The lens formula. Focal length, origin distance, image distance. M is for linear magnification. H1, HO, size of image and size of object. And alright, okay. So this is some questions, but it's okay to know. But alright, it's okay. We forget about it. So okay, this is the concave lens formula. which is 1 over f is equal to 1 over u plus 1 over v. F is the focal length, which is the distance between optical center and the focal point, is equal to 1 over u plus 1 over v.